For this case, the integral of x squared divided by quantity x minus 2 to the third power. This one considered as linear factor with the power 3. Power 3, that means your m is 3. So for this case, since this is the linear, when you do the partial fraction, gonna be the first fraction of the power 1 plus the second fraction of power 2 plus another fraction of the power 3. So you're gonna have like 3 fractions of the linear factor from power 1 up until power 3. And since they are linear, the numerator gonna be the constant term. So I use A, B, C, and with respect to X. You can use A1, A2, A3 if you like, okay? The next step, we're gonna have to find A, B, and C to make the original the original expression or the original integrand equivalent to the sum of these 3 factors. To find the values A, B, and C, I'm gonna add more slide again and then work on the details. So right now we are on the prep work, okay, prep work area to find A, B, and C. And to find A, B, and C, starting with writing the original expression, which is x squared divided by the quantity x minus 2 to the power third. And then the first fraction is A divided by x minus 2. Second one, B divided by quantity x minus 2 to the power second. Last one is C divided by x minus 2 to the power third. Same process. You gather the 3 terms back into one fraction. So the common denominator would be the power 3. If the common denominator is the power 3, that means I'm going to multiply the first term by x minus 2 to the power second, x minus 2 to the power second. I'm going to multiply the second fraction by x minus 2, both top and bottom. But I don't have to do anything with the last fraction because the denominator already in the power 3. So the first term going to be a multiplied by x minus 2 squared. Second term is b times x minus 2, just the first power, and then plus c. The left hand side, one single term. The right hand side, we have one single term as well, but in the form of ABC coefficients in there. And then the next step, I'm going to equate the numerator on the left and the numerator on the right. That means, so this part, we equate the numerator. So x squared equals a times x minus 2 squared plus b times x minus 2 plus c. Okay, so I'm going to choose my convenient number again. In this case, you can expand them all out and equate the coefficient of each part of the x, which a lot of algebra work to do. So what the preferred method for me, I pick convenient numbers. Since I have to find the 3 numbers A, B, C, so I'm gonna pick like 3 convenient numbers. What do I mean by convenient numbers? I'm gonna look at the number that eliminate the terms that make me easier to find one of the unknowns. For this case, if I pick the value 2, I can eliminate the group of the A and the group of the B, and I get the value C out. So my first convenient number is x equals 2. If I pick x equals 2, the left-hand side becomes 2 squared or 4. And then the A term gone, B term gone, because I subtract 2 by 2, right? So I get my value C. My C is done. I set it aside. So I have to pick another convenient number. In this problem, I don't have any very nice number that could eliminate the number out of the way. So I'm going to pick the one that's convenient to compute. For example, x equals 0. You can pick any number that you like. You just have to work on cleaning up the number or simplifying the quantity along the way. If I pick x equals 0, my left hand side is 0. The right hand side going to be a times negative 2 squared, which is 4a, and then 0 minus 2, that is negative 2, so minus 2b, and then plus c. My c is 4 from the first round of substitution. So this case, I will have uh, 4a minus 2b equals negative 4, okay? Or I can rewrite it as, because I see 4, 2, and negative 4, I just write as 2a minus b equals negative 2. Set it aside, okay? We're going to come back because we still have two unknown. I'm going to pick another convenient number. I just use a low number because it's easier to compute. If I pick x equals 1, my left hand side going to be 1. My right hand side going to be a times 1 minus 2 quantity squared, which is a times 1, or just a. And then b times 1 minus 2, which is negative b. And then plus c. Again, my c is 4, my known number. So right now I have negative 3 equals a minus b. Okay, I have two equations. So what I could do, I could solve this for b. So my b equals a plus 3. I just rearrange the term by adding b both sides, adding 3 both sides, and then I substitute into my equation that I set it aside from using x equals 0. So then I will have 2a multiplied by a plus 3 equals negative 2. Then I have a minus 3 equals negative 2, or my a is, I add 3 both sides, right? My a is 1. When I have a is 1, I put it back into my expression for b. So what I get, I will get b equals 1 plus 3, which is 4. Okay. Right now we have a equals 1, b equals 4, and c equals 4. And we're going to bring our numbers to the problem. So this, again, this is the prep work as I mentioned earlier. So next, we're going to add another slide and then work on the detail. From the integration, I rewrite the problem again, okay? So x squared over quantity x minus 2 to the third power with respect to x decomposed to be a divided by x minus 2 plus b divided by quantity x minus 2 squared plus c divided by x minus 2 quantity to the power 3 with respect to x. My a is 1, so going to be 1 over x minus 2. The b is 4, going to be 4 divided by x minus 2 squared. And c is 4 as well, so plus 4 divided by x minus 2 to the power 3 with respect to x. To find the antiderivative, the first one I use the u-sub, u equals x minus 2, so the du is dx, okay, which from the integration of 1 over u du. So the first term, I will have the just natural log of absolute value of x minus 2. The first one done. The second one, this one is in the power form. So I rewrite it as 4 multiplied by x minus 2 to the power negative second, which is similar to the last one, which is 4 times x minus 2 to the power negative third. Okay, both of them I'm gonna let the u this one, so u as x minus 2, and then du is dx, right? So the first term becomes the integral of 4 times u to the negative second. The second term is 4 times u to the negative third with respect to u. It's not the natural log as a result of the antiderivative. You're going to use the power rule for this antiderivative. Then we're going to get the first term as plus the 4 times u to the negative first over negative 1. And the next one is 4 times u to the negative second over negative 2 by using the power rule. And what is the u? U is x minus 2. So I just rewrite everything back in terms of the x. Negative and 4 becomes negative 4. Reciprocal, negative 1 becomes a reciprocal. So I'm going to bring it down here. And similar to the last term, which is 2 divided by the quantity x minus 2 to the power second, and then plus c. So this is the answer for this problem. If you want more detail, so this one means negative 4 u to the negative first, which is negative 4 divided by u, and that what how we get. And similar to this is negative 2 times u to the negative second, or negative 2 divided by u to the second, and replace u with the x minus 2 to get that term. And this is our answer.